These are my RGB light bars. Made them myself for $40. Let me show you how. Hey everybody, how's everybody doing? This is STEM Studio. My name is Kevin Duran, and I'm here to talk to you about the light bars, those RGB light bars. You know, I've always been impressed with other people's streams and their YouTube channels. You know, there's something really cool about just the lighting effect that goes on in the background. I've always wondered, could I just make those myself? And after researching online how much they cost, the only option was, let's just make that yourself. Parts I can get from hardware stores and the RGB lights that I already have laying around could be the difference between going out and buying these lights and finding a way to create it myself. And so I put together what you see behind you. So you can see it can be done. Now, I'll tell you, it's not as professional looking when you look at it up close. This looks very DIY up close, but from the background, look at it. It's amazing. Another thing I should warn you about, you are going to have to learn a little bit about coding to be able to get this project completely done. You don't have to be able to be a coder or a computer programmer, but you will have to start the process of looking at code and understand what part of the code changes what colors so that you can make your light bar look like what you want it to look like. So with that being said, let's just jump right into it. Here's what you're going to need to get started. The WS2812 RGB lights from Amazon, $17.99. From Lowe's for $1.98, 3/4 inch slide out elbow. For $2.23, 3/4 inch PVC pipe. From Lowe's, I bought a 5/8 inch poly tubing for $9.84. You will also need to purchase, if you don't have one, an Arduino, either a Nano because of the small size, or you can also use an Uno. Costs are ranging from $5 to $20. Tools that you will definitely need for this project: a table saw, PVC cutter, hot glue gun, hot glue, utility knife, and scissors, and maybe even a clamp. Okay, step 1. Using a table saw, strip cut right down the center the PVC into 2 halves. They should look like 2 long half moons. Step 2. The 2812 RGB has an adhesive strip. It's worthless. Place it in using the adhesive strip, but then hot glue it in. Take every couple of inches and put a little bead of hot glue so that it stays in place. Step 3. The poly tubing, that 5/8 poly tubing, fits perfectly into the 3/4 inch PVC pipe, so it will sit right on top of the lights once they are adhered to the tube. Step 4. Take time to hot glue in the poly tubing to keep it with a good seal. Now on to plugging in the Arduino. You're going to need 3 jumper wires, preferably red, green, and black, although any colors will do. For my project using Nanos, I also have a small breadboard and the Nano so that I can use a male-to-male jumper wire. Now that I have my Nano plugged into the breadboard, I can plug my jumper wires directly into the breadboard right next to each one of the pins. This allows me to take each pin and connect it into the appropriate inputs for the RGB. The black input on your RGB is your negative or your ground. The green input, which I'm going to plug into the green wire, is your data line. And the red input for your RGB is your 5-volt power. And lastly, for me, I use pin number 3 for my data line. So my green wire goes into D3. And then I plug each wire into the input for the RGB. And that's it. If you made all of these connections correctly, congratulations. Nothing's going to happen. Aww. Now you have to program it. This is one of the drawbacks and the benefits of making your own. You get to design exactly what you want that bar, what you want it to look like, but you also have to know enough about programming to get your light bar to do exactly what you want it to do. We're going to show you a quick and easy way to get code that's already written set up for your light bar. This is going to be a fast intro into getting an Arduino board set up and receiving code. So what is an Arduino? An Arduino is a microcontroller. Those tiny pins can transmit and receive electric signals and electrical currents. For our purposes, we will send a signal out to the RGB light and power the lights with our other 2 pins. To get your Arduino connected to your computer, you will need a computer, the USB cable that came with your Arduino, and the Arduino IDE, which stands for Integrated Development Environment. We're going to load this now on our computer. You want to navigate to or type in arduino.cc or just type in Arduino and look for the main page. On this main page, you're going to see software. Click on downloads. Immediately on that page, you will see where it says download the Arduino IDE. Depending on what kind of computer you have, you want to download the installer for Windows. You can also do a Windows app, or if you have a Mac, you can put it on your Apple. This is a community, an open source community that makes it available for everyone for free. But if you feel generous, there's places where you can donate money, or you can just download. I've donated before, so I'm just going to download. Once your download is complete, you should be able to run the application, and your Arduino IDE will look something like this. The Fast LED library. Under Tools, go to Manage Libraries. It'll take a second to load. If it's not already here, you can type in Fast LED, and you'll want to pick up the Fast LED by Daniel Garcia. And once it says installed, you can click out of the manager, and that's it. And still nothing is going to happen. To find that code, go to File, go to Examples, and at the bottom of Examples, you should see where it says Fast LED. The one that you see behind me is the Fire 2012. Immediately it comes up with the code that's currently running my RGB light bar. There's a few things in here that I need to change. I know that I plugged in my LED to pin number 3. I need to change the chipset of the RGB lights because mine are WS2812, not the WS2811. Change that to 12. I need to go here and look to see how many LED lights that I'm pushing. In the strand that I have, I've counted before, there are 60 individual LED lights on that strand. I can leave the brightness the same. I can leave my frames per second. Hey, time out. Future Kevin, I'm here to help past Kevin. In your code, just make sure that your brightness level doesn't go beyond about 100 for any one of these different programs that you're going to try. The reason I say that is because at full brightness, it takes more power than the Arduino can give to be able to power all of those lights. It's still 5 volts, but the problem is amperage. Your light bar will work great if you have 60 lights as long as you're not trying to power them full bright. And the solution is keep your bright level between 60 to 100. They're bright enough so that you'll be able to see them. They look great and you won't damage any of your components. Back to old Kevin. And right now, without doing anything else to this code, I should be able to push this into my Arduino Nano. Before your Arduino is going to work, you have to do one more thing. Be recognized by your computer. Come down to Tools, look under Board, and you can see all the different flavors of Arduinos that are out there, and find the one that represents yours. You'll have to go back to Tools and find which port that your USB is plugged into. This arrow verifies that you haven't done anything wonky to the code that it can't compile it. So if you hit verify, it just justifies that everything in the program is still going to run like it was first designed. It compiles the sketch, it lets you know when it's done, and then if you don't get any errors and you don't see anything red, you're good to go. Once you have that, you click upload, and you watch the light show. And there you have it. You have your LED RGB light bars. So here is the Fire Stick, and here is another one off of the Fast LED. You can try out all different ones within that library. It's exciting to start the process of looking into the code, finding out how you can modify it, and really discover the power of having your own light bar with a programmable Fast LED light code. Let me know if you're going to create this yourself, or let me know if you've already created one, or let me know if you need help. Put it in the comments below. Have fun, be careful, and enjoy the process of learning. This has been STEM Studio. I'm Kevin Duran, and we'll see you on the next one.